Welcome to Web Handling. My name is Dave Roysum. Pneumatics are a vital part of web machinery. That includes nip control, as we've described in the last few clips. That also includes tension control for many unwind brakes. That also includes a range of other components, from delicate slitters to the brutish roll set change components. In this clip, we describe best practices for pneumatics. We have two basic options for caliper and cylinder control. Pneumatics are the most common because they are clean and cheap, and they are the subject of this clip. However, hydraulics have superior performance in many ways and are the subject of the next clip. Long-term performance and reliability starts with clean air. Best practices are exemplified by paper mills. They have two air supplies, clean and super clean. Actually, they call them mill air and instrument air. Mill air does most of the work. However, fussy applications such as slitter blades require much better air. It must be kept free of water by good compressor choice and maintenance, sloping pipe runs, water traps at the low spots in the piping line that are regularly purged. This is all before you even get to the local water separator, local filter, and local oiler if appropriate. Yes, some of this is also done with mill air, but it is not as good. The purpose of this extra effort and redundancy is to keep water from destroying lubricants and rusting metal. By design, components such as brakes and cylinders should be sized to keep the pressure in the 7 to 70 psi or 0.5 to 5 bar range. Lower pressure settings result in variability. Higher pressure settings cannot be guaranteed in every plant. For unwind brakes in particular, it is difficult to size a single component to stay within this range. That is due to the changing unwind radius, changing web width, and changing web tension needs. To accomplish this on an unwind, we may need to use multiple calipers and use only the number needed to keep the pressure in that range. It is usually a good idea to pipe to the center on all but the narrowest of machines and then to tee off to both sides. It is also a great idea to pipe both sides of most every cylinder for many reasons, including those given below. One side, the fixed side, should be tared or zeroed as we described in the first two clips in this series. Airflow sizing should be more than fast enough for peak total demand, but then you control the speed in each direction of each cylinder by needle valves on the exit side. Short, stiff piping runs will improve response. In most cases, we should use 4 to 20 milliamp I to Ps rather than 0 to 5 volt E to Ps. And this is for signal reliability, especially in environments with high currents, such as near electric motors. Having a local pressure gauge on the cylinder or brake can greatly improve maintenance and troubleshooting. Finally, for pivoting systems, such as some lay-on rollers, it is best to limit the motion to less than 70 degrees, else the force to pressure ratio gain would vary excessively. Pneumatics are a very useful choice for unwind brakes and nip cylinders because they can control torque and force respectively. However, this is only up to a range of about 10 to 1. Beyond that, control quality is lost on the low end and/or capacity is lost on the high end. You can do logic with pneumatics even without a PLC. What a lot of people also don't know is that you can also do simple math. Both of these are illustrated with rider roll nip load curve control given on the title slide. However, pneumatics can't do everything well. Speed is at best crudely controlled and bouncy, especially at the start of a stroke. Also limiting is the ability to control position anywhere mid-stroke. Even controlling position at the ends of a stroke are challenging because you need to slow inertia down without taking out the ends of the cylinders. Internal spear cushions and external shocks are some ways to do this. Thank you so very much for watching this module in my Plant Practical series. Please stay tuned for the next clip where we both curse and praise hydraulics.